Okay, guys. Today is kind of a fun day. You can send messages to your friends.
We need all beginning percussion to be excused at this time to go to the auditorium.
You can send message to your friends in code.
Ooh, I like this one.
Yeah, it's on, I'm telling you, you guys have a code on your test.
Yeah.
And
Cool.
you might even see what the code's going to be. But if you don't show me the work, I ain't giving it to you. Okay? So I'm just telling you flat out, maybe the code's easy to see. Okay, today's 8-5. Today is also another way to solve an equation. And today, guys, is almost a whole calculator day. Okay, there is.
We're gonna have.
Okay, stop. Today is Cramers Rule. Okay? Which has this. Let's write an equation here. Let's say 2x minus y. I'm going to plug in x is 2, y is going to be 3. So 2 times 2 is 4, minus 3 is negative 3, so that comes out to be 1, right? So notice my x again. Let's say this is 4x, and this is 5y. Once again, what was my x value again? I said 2. So that's 8, and this is negative 15, so that's negative 7. Sometimes that's how I write my equations of things. I pick out values. So I already told you the answers. What's the answers again? X is 2, y is negative 3, right?
No,
Just 3? Oh, damn. That's not the right answer then. I thought we said negative 3. So that's 2, so that's 8. And that's 3, so that's 15. So that's 23. Does everybody see that? Okay, so here's Cramers Rule. Okay? Cramers Rule tells you to find the determinants of your matrix. Okay, now obviously with the 2x2 guys, I'm telling you right now, if you have 2x2s, do you guys see how easy it is to find the determinant? This minus this. Yeah. Is it worth the time to put it in your calculator? Let's be honest. No. When would you put it in your calculator? 3x3s and so forth, right? Okay, here's what they tell you to do. You're going to make up, in this case, 3 matrices. You're going to call it D, which is just, you use just the coefficients. So that's 2, negative 1, 4, and 5. I'm going to use dx. You guys catch up, so don't mustard around. Okay, dx, now this is Cramers Rule, right here. Cramers Rule. Okay, Cramers Rule tells you to do this. Okay, with it being dx, guess what I'm going to do? I'm going to put my answers in for the x column. So notice this is 123, and I still keep my y. So what do you guys think dy is going to be? I'm going to put my answers in for the y. No problem. Watch what I'm going to do here. So dy is I'm going to replace my answers for the y things here. So therefore I'm going to still have 2 4, but now I'm going to have 123 instead of negative 1 and 5. Does everybody see that?
Yeah.
Okay. So we hurry and find the determinants. How many determinants do we need to find? We need to find 3. So this guy, D, is going to equal 10 minus a minus 4, which is 14. Can everybody see that? Anybody have a question there? Okay. Then on this one, dx equals 5 minus a minus 23. So that's 28. This is the easiest method of all, besides using your calculator to solve an equation, is this rule. Then you got 46 minus 4, and that's 42. Okay, now you might be asking, how's this solving? Well, ladies and gentlemen, what you do now is x equals dx over d. And what was our dx? 28 over d, which is 14. And what's 28 over 14? Isn't that what I told you it was going to be? Okay? And then dy, what do you guys think y is? dy over d, which is 42 over 14, which is 3. We just solved for x and y. That's pretty simple, huh?
Yeah.
And that was pure head. Right? Do we need a calculator for that? It's pretty cake, huh? You know what I mean? That's part of our lesson today. Okay, so now obviously we have a 3 by 3. Okay? I don't know what the answer to this is. Let's make it up. So we got x plus y plus z equals 2. And then maybe I have an add 2x minus y equals 7. These might come out nasty fractions, but it is what it is. And then we'll say 8x plus 5z equals negative 3. Okay, this is what I am expecting for your work. Because is this a calculator-based one or a non-calculator-based one? This is a calculator-based one because if you were going to try to find the determinant of, you're going to have how many matrices on this one? 4, because you're going to have D. It would be our D matrix. It'd be 1, 1, 1, right? 2, negative 1, 0. 8, 0, 5, right? And then now we need who else? Dx. Now, the problem of this is you need to be very careful what you plug in. Okay? Okay, what's dx? Can anybody, let me pick on somebody to see if you can give it to me. Danny, you want to try for me, bud? Remember on the last one?
Yeah.
When I did dx, I replaced the x values with the answers.
So do you want me to go down?
Let's go sideways.
Okay. So 2, 1, 1,
Good.
7, negative 1, 0,
Good.
negative 3, 0, 5.
Awesome. You guys see what he did there? He replaced the x column with the answers. Okay? Does everybody see that? Notice he replaced the 2, 7, through negative 3. He replaced this stuff with the 2, 7, and negative 3. Okay? Trilby, I saw you looking back there, so you're up now. You at least have the paper to look at. dy. Well, basically I can get it right here as well. dy. Now you're going to replace the answers in for which column? The y column. Does that make sense? So you're going to still use this guy, 1, 8, 1, 2, 8. But who's going to go in my y column? Look at your paper because it's up above. Oh, you didn't write it?
No, I can't really see. I didn't do it.
Johnny, you mind switching her today? I didn't know. I would have hooked you up later. That's why you're giving me that dirty look.
No, I'm not.
Thanks, John. We'll record. Here we go. So notice I'm going to still put in 1, 0, 5. Because remember, we're replacing these answers into the y column. So, what goes in there? There you go. I'm sorry you're blind today. What's dx? I know you guys have the paper. That's easy, excuse me. 1, 1, 2.
8, 0,
Okay. Now, the hard part is what? Punching a million numbers. Okay, so here's what I do. Okay, so we go to our calculator.
Alright.
Okay, okay, so we're on, push you over here. Okay, so, thank you. Why do you mock me always? I'm a little sailor. Maybe I should have been in the Navy. In the Navy.
Maybe.
Oh, I think they say worse. Okay, so there's D, right? I just plugged in D. So guess what I do? I go back and I hit quit, go into my matrix, over to the math. The determinant of matrix A is -7. Okay. Does everybody see that? Now, why didn't I put all 4 in? Well, here's my reasoning. Because now, well, maybe you should do all 4. But at least for the first one, dx, it's really simple. If I go second matrix over to edit, okay, notice now I just got to come down here and say 2, enter, and then push over and go here. So I don't have to change everything. Does that make sense? So 7, arrow down, and -3. Okay? Second quit. And now notice I've already said determinant of A. Now I've got it again, so I go, just watch this, second entry. I don't have to do anything, it's -48. All I did is hit second enter. And it should pull up the very last thing you just did. Okay? So now I go back in again, right? Matrix, edit. So now, this is what I do, is I go 2 here, 7 here, -3. I'm just using my answers, right? So now I got to come back over here. What was that? What was the original? So we come over here and we look at it, and it's
1, 2, 8.
8, 2, 1. Then I get it out. Second enter. So I don't have to go find all that stuff again. I just have to hit that. -47. So this was dx, right? dx was -48. dy was -47. Now we go to dz. Okay, so I go second matrix, over to edit, 3 by 3. So notice what I do here. I put my 2, my 7, come on. And then I use my -3. Okay, and then I come over here. Sorry. This was a 1. That's a 1. -1, and then 0. Second quit, second entry, that's 81. So, I'm done with you. So, scroll down, woo, too far. This guy's 81, right? You see what I'm saying? Now, is this the fastest way to solve this? No. Obviously, the reduced row echelon form is the easiest one, right?
Yeah.
Okay, and then notice, so I have x equals dx over d. My x value was -48, wasn't it? Right? Was that correct? Over 7, so there's my x value. My y, this is exactly what I want to see for your work as well, for even a calculator problem, right? Because then it's showing me you know what to plug in, so if you have a mistake, I can at least say, well, you understood what to put in, you might have missed that. Does that make sense what I'm saying? Is it a -7? So that's 48/7, sorry. And then dy over d, which is -47 over -7, which is 47/7. And then z equals dz over d, which is 81 over -7, which is -81/7. Now mine came out nasty because we made it up, right? I don't know if yours is going to come out nasty or not, but if you have a machine, does it really matter? No. You get what I'm saying? Are you okay using yours? You got it down? Okay. That's half our lesson today. Okay, we're doing okay? The other things that matrices can do for us is it can find the area of a triangle. Okay? All it does is this. Okay, this is something you need to memorize. Okay? So if we have, how many points does a triangle have? A triangle has points, I'm going to call them x1, y1, x2, y2, because notice this represents the 3 points, x3, y3. And all you have to do, the area of a triangle equals plus or minus a half, and I'll explain why there's a plus or minus there. The determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay? So once again, what do those mean? What does that x1, y1, x2, y2, and so forth mean? What does that mean?
Points.
They're just points. Okay? So, let's just say I have the point 1, 2. I'm going to draw it down here. 1, 2, 0, 0. And then let's use 1, 0, just for kicks and giggles. And then notice we can already see the area of that triangle, can't we? What's our base? 1. What's our height? 1, right? Oh, excuse me, 2. So 1 times 2, so that's 2. What's the area of that triangle going to come out to be? 1. So notice when we plug this in, okay, so I have plus or minus a half, 1, 2, 1, 0, 0, 1. This is going to be faster to do it not in the calculator than with the calculator. Can anybody tell me why?
There's lots of zeros.
Look at that row with 0, 0, 0, 1, right? That's easy just to use a minor cofactor and get the hell out of the way, right? Yeah. Virgin ears. None of you guys have virgin ears anymore, supposedly. From what
Shout out to
Haley
Jamar.
says. So I'm going to use this row. So what's with this 1? Is he a plus or is he a minus in our sign chart?
No, minus.
He's a minus. Does everybody understand why he's a minus? Because notice plus, minus, plus, minus, plus, minus, right? You can be a negative. And notice these guys are 0. So we just got to worry about negative 1 with the determinant, row, column. What's that? Oh my goodness. Did I do that wrong?
Yeah.
Yeah.
It should be 1, 2, 1, 0.
Oh. No? Oh, yeah. Oh. We should get rid of this and this. So it should be 1, 2, 1, 0. I was like, what the hell's going on? Okay.
Yeah.
So this is 1. This is 0 minus 2, which is negative 2. What's negative 1 times negative 2?
2.
Now, why, guys, is there a plus or minus? What can determinants come out as? They can either come out as positive or they can come out as negative. So who am I going to use if they come out positive? The positive a half or the negative a half? What does area always have to be? Can it ever be negative? That's why if you have a determinant that comes out negative, you're going to use the negative a half. If it comes out positive, you're going to use the positive a half. Does that make sense? Right? Okay, so notice we have a half times 2, which is 1. And notice that was the area of our triangle that I gave over there. What? Let me just ask you a question. What if your determinant comes out to be 0? Let's think about that. What's your area of the triangle then? How can an area of a triangle ever be 0? Well, it's not a triangle, is it? What is it? It's a line. You just said it, I think, right? Think about that. Because any time, if you have 3 points, okay, and if one's just barely off that line down here, don't you have an area? Even if it's very small and very small, right? You'll still have an area. So if you have 0 area, that means you're all in a straight line, which means you are collinear. Okay? How many points do you have to write a line? 2, right? So here's how you write a line using matrices. Okay, so we're still going to use this formula. Okay? Somewhat. So, this is the equation of a line. And here's what it is. It's x, y, 1, x1, y1, 1, x2, y2, 1. Can somebody tell me, and that equals 0, by the way. Can somebody tell me what that means? Well, for an equation of a line, don't we have to have the value x and y? Right? Okay. What does this x1 represent?
Point.
It's a point. What does the y1 represent? A point. How many points do you have to write an equation of a line? You must have 2, and hence why we have 2 points here. Does that make sense? Okay. So let's draw one really quick. Let's say we had 0, 2, and we're going up 3 over 4. So notice our equation of our line would be 3/4 x plus 2, correct? Okay, a nice point that we used was 0, 2. Let's not use 0, 2. So we went up 3 over 4, so that's point 3/4. And then we can use 6, 8. Those are both points on that line, okay? Can we do that? Everybody understand that? Notice that we should get that equation y equals 3/4 x plus 2. Okay, you guys ready? All right, here we go. So we go x, y, 1. What's my first point I'm going to pick? Does it matter? Nope, so I'm going to use 3, 4, 1. Then 6, 8, 1. And it should equal 0 because why does it have to equal 0? Because isn't this basically, guys, what is this? This is the area of a triangle, right? And if the area of a triangle is 0, that means they're a line. And it's the same formula, you just got to remember the plus or minus with the area one, right? Does everybody know the area of a triangle in general when we just tell you? 1/2 base times height, right? So if you remember the area of a triangle, hopefully you remember the 1/2 as well for the area of the triangle with the matrices. That's how I remember it. Does that make sense?
Yeah.
Yes, ma'am.
Can you get the 3/4 cents?
Because notice, remember I rose 3 ran 4.
Oh, is that the?
And that's going to be what our answer is going to be.
Oh.
So we're just going to show you that it does match up. Yes, ma'am.
So you get the 3 and the x1, the 4 and the y1.
Because those are points, right?
But
And so 3 represents an x. The x1 represents, anytime you see a subscript, what that really represents is a point. Notice, remember when we did things back in the day, slope, it was y2 minus y1 over x2 minus x1. What does that really mean? Well, that's the y value of a point, and that's the x value of that same point. That's what that means. Subscripts mean points. Does that make sense to you?
Yeah.
Are you okay with that? Aren't you a percussionist?
Yeah.
Why aren't you going?
I'm not against the question.
Oh, they said beginning, I remember. Okay. So, now notice, can you use this in your calculator? No offense, guys, it's got x and y, so it's not going to happen. So, which probably lane or column or row or column are you going to use? I like the either, oh, actually the top one would probably be the easiest. So notice this would be x, would y be positive or negative? Negative y, would 1 be positive or negative? Positive. Does everybody see that? Because of the sign chart, right? Okay, and notice if I get rid of the x, what's left over? 4, 1, 8, 1. How about with the y, what's left over? 3, 1, 6, 1. If I get rid of the 1, what's left over? 3, 4, 6, 8. Does anybody have any questions on how I got those using my minors and cofactors? I know I'm kind of chugging along, but I'm trying to get to the code. Okay, so it's a cheese. Anyway, this is 4 minus 8, which is negative 4, so you have negative 4x minus 3 minus 6, which is negative 3, so negative y times negative 3 is actually plus 3y, right? And then this is 24 minus 24. Ooh. Uh-oh. Oh, damn, that ain't the point. Okay, I understand what I did wrong. plus 0 equals 0. Those technically weren't the points for that equation. So now we want to always, whenever we solve an equation, we solve for y, right? So I'm going to add the 4x over it. So 3y equals 4x. And then we divide by 3y equals, somebody I think called me on this too, didn't you? Should it be that too? Oh, yep, never mind. I did totally wrong. Okay, that is the right equation for those points. Because notice, where's our points at again? 3, 4. And 1, 2, 3, 1, 2, 3, 4. We did it right. It's just so 3, 4, 6, 8, 9. So you're going to go through 0, 0. Go ahead. And how much are you rising? Rise 4, 1, 3. So we did correct with those points. Those points I should have used for this guy. Notice if I'm here, I'm rising 3, running 4. So that point is what? Rising 3 from 2, that's 5. Running 4, that's 5, comma 4. Rising 3, that's 7. Running 4 is 9. So that would be 9, comma 7. Should have got those. Sorry about that. But do you guys see where that's coming from? Are we still okay to see how it can write an equation of a line? Yes, no? Pretty cool? So what do you have to memorize? The area of the triangle. And if you basically memorize the area of the triangle, you can use the equation of the line. What if I ask, are these points equilateral? How would you, not equilateral, equilateral, no? Not equilateral. Collinear. Damn, I can't even remember my words. Collinear. Okay? So,
You remember what word in particular?
darn. So, my daughter the other day, she's like, damn that mailman. And I'm like, honey, you're not supposed to swear, but Dad, you shouldn't swear either. I'm like, you got me. She gets a lot of swearing from her mom. Does she? Okay, so now is the code. Okay? This is a fun time. So, what you do is, for example, I'm going to say hello class. Okay. I have it, it's in here in your book. A represents 1, B represents 2, C represents 3, Z represents 26. You guys get what I'm saying? Okay, guess what 0 represents? A space. Okay, so H in the book says that's 8. E is 5. L is 12. 12. 0 is 15. A space is 0.
Oh.
No, I did O. I did. I must have said something else. I'm sorry. C is 3. L is 12. 1. S is 19. 19. Okay? So, we just scrambled our message into something. Now, if that's a very basic code, I think somebody could break that. Right? Okay. So, what you do is you group them into 3. This guy doesn't have a third one, so what can we put on the end?
Yeah.
A 0 for a space. Okay? Now, you go ahead and you make up your very own matrix. Whatever you want. Okay? Just bear with me. It needs to be at least a 3 by 3. Or at least needs to be a 3 by something. Right? No, put 3 by 3. Because you have 3 columns. Yeah. Okay, so let's say A is 1, 2, 3, 4, negative 2, 1, 0, 0, 5. I'm trying to make it easier. I do give you the matrix. Because we need to all have the same matrix, right?
Yeah, to make the same.
Does that make sense? Yeah. Okay. So, ladies and gentlemen, guess what I'm going to do? I'm going to multiply this through. Okay? To get me my new thing. Because notice this is a 3 by 1. Right? Multiply it by a 3 by 3. What do you come out to get? Hold on. Let me make sure. It's been a while.
No, that's a 1
No.
3, isn't it?
That is a 1 by 3. Switch it. Okay, that's what I did wrong. That's what I did. Something's wrong. 1 by 3. Okay? So I take this row, multiply it to all the columns. Okay, this is how you would send a message. So I'd go 8, 20, 0. 8 plus 20 is 28. Notice that's 1, 1. 8 times 2 is 16, minus 10, that's 6. That's 24, plus 5, that's 29, plus 60, that's 89. Yes, ma'am?
I'm trying to use one of your top.
You just group them, you always group them in threes.
On
That's how we're going to do it on the test. So group them
the,
by
like the
threes.
last one or 2 left?
So therefore I put a 0 with it, because then it made a 3.
How'd you get from the?
I made this up. You just make this your own matrix. Each of your buddies have it that you're sending it to. I know you're not going to do this, but you get the idea. So this is really how, like, if you've ever watched a movie, like how they have code breakers. Have code breakers. That's where stuff can come. This was kind of how they had their own little things to send messages through, because they each had the same thing. I'm not joking. That's really something truthful. Okay. So then, now I take this guy. 12. That's 12. Oh, 4 times 15, 60. That's 72. 24 minus 30 is negative 6. 36 minus 15 is 21 times 0 plus 0, 21. Anyway, you get what I'm saying here, right? I don't have enough time to keep going. Do you guys get what I'm saying?
Yes.
So this is the code that you would send to your friend. Obviously, you're going to have 4 sets of them, right? Does that make sense to everybody? So, go ahead. Oh, did I not explain it? So you take, it's just timesing now, row by column. So 8 times 1 is 8, 5 times 4 is 20, 12 times 0 is 0, 8 plus 20 is... You get what I'm saying by that? Okay, and I just took that to all 3 columns. Okay, so then you send your friend this message. How is he going to figure out what the message says?
He's going to use that matrix.
He's going to use this guy's matrix, but how do I get back to what his original message said? I can't divide matrices. Times by its inverse. So, what you're going to do, and I'm just going to do one of this with us, okay? Go to my calculator. I'm just going to do this guy right here. So I go in, matrix, oops, I turned it on. Matrix, 3, okay? So, 3 by 3. I have 1, 2, 3, 4, negative 2, 1, 0.
Oh, that didn't work. Hold on.
Okay, 0. I'll come back to it. 0, 5. Where did I mess up? The 1 up here?
You put a 5
I will put the, man, I just messed the whole damn thing up. Darn thing up. I'm really sorry. It's just, it's me. Just get used to it. If not, I apologize. Not, well, yeah. Nothing.
I have to.
No. That guy's a 1 by 3, right? So then I have 28, 6, 89, right? Okay, so what you're going to do is now you're going to times this by this guy's inverse. Does that make sense? So I'm going to go matrix B times A's inverse. And what do I get? 8, 5, 12, and then you start uncoding. So what I'm going to do on your test,
You do that each time for each.
then you're going to get, so now I could use this guy, you know, and put him as matrix C, and then go C times A's inverse, and that'll give me these guys. You get what I'm saying? That's how your brother got extra credit a couple years ago. He sent me a message. On Brownie. And it said USC Trojans or Go Trojans. Anyway, but that's how you could do it. And then you just say, okay, well, what is 8? You look at the list. Oh, that's 8. You know what I mean? Then you go back and decode the message. Okay? So what's going to happen on your test is I'm going to give you this. This is the message. I'm going to give you the matrix that tells us to uncode it, okay? And then you're going to get the code that uncodes it. So basically, you're going to plug this in your calculator, you're going to plug this in your calculator, right? And then you're going to go this times A's inverse and start uncoding the matrix. Does that make sense to you?
Yeah.
Okay. Yeah, that's a calculator section. Okay, sorry. Really close. We have 8-5. Thanks, Emily. 8-5. 1 through 57, every other. Thanks, guys.
I need the following students to the front office: Catherine Pearson, Christian Uliberry, Kyle Norton,